We are live now. So, hey folks, this is me, Vishwas Nair. I'm the host of this Build Piper show. A lot of times, we have already been through a lot with respect to our journey in order to get started with how can we scale systems without compromising the needs about getting into the system level designs and things like that. And there is always a complexity that is getting added in terms of the particular design and things like that. And there is always a new way in which the things get changed when we talk about the scale, the deployments, and the things like that. So the worst case scenario is there is a new definition for it because Kubernetes is coming up with new startups, new use cases, new securities for it. But there is still a lot to be changed. There is still a lot to be covered from our side. So let's get some things to be started off. And in the meanwhile, Nilesh can share his insights on Kubernetes 101. And Nilesh, you can go now. I'll be sharing the screen now, right now. So yeah, I'm able to share your screen, so you can just go with the presentation mode now. That's perfect. Yes, I'm able to see your screen.
It is visible now?
Yeah, it's visible.
Cool, cool, cool. So, hello everyone. My name is Nilesh Shinde. I am basically from Mumbai, India. So, this is a little bit about me. Like, I work with KPMG India as an associate consultant, where I serve Indian banks as client and we solve their data problems. Also, in my free time, I love doing community work, that is, community building in developer space. So, currently I am a part of these many communities like Azure developer lead for Mumbai and Navi Mumbai. Then I am also a part of CMX Hub, which is a global community of community managers. And there is two more communities: Elastic User Group, Kong Meetup, and I'm starting a new chapter for Data Visualization Society Mumbai very recently. You can connect me on my socials if you want to discuss more about technology in general or community management. So let's jump in today's topic. So I'm going to give you a very brief idea about what Kubernetes is and why to use it. So before jumping into the agenda, basically we need to understand what our microservices are. So basically, there are two types of architecture majorly, that is monolith and microservices. So monolith is like you run your application, everything as a whole, and on the other side, microservices are like you break down your application into multiple parts, so you can manage it properly, you can run it properly, you can keep your team separate. So these are the important parts of microservices. So uh, to implement microservices, there are different technology stacks. So let's consider for now Docker containers. So container is nothing but uh, a image. It is a lightweight version of an application. You can say, suppose I want to run an app uh, of a particular kind, and so for that I need the code and the underlying runtime or underlying environment to run that app. So Docker container is nothing but a lightweight standalone package of these things that contains your code, runtime, other system tools, and libraries that helps running your application. So why to use Docker? So Docker is a very widely known technology nowadays. It is simple to use. There are a lot of images present on Docker Hub. So Docker Hub is a platform where you can uh, check out other images like what people have built, or you can upload your own images for people to use it. Using Docker, you can create new images based on your previous images. Image is nothing but a collection of files which helps in running a application. Also, Docker supports almost all the platforms like Linux, OS X, uh, and Windows. So let's briefly see about the history of Docker. So as you can see on my screen, how Docker evolved eventually. So I'll you know I'll give you a minute or so to check out the content on this slide, so you can go through it, how Docker actually evolved from the JLS to the current Docker version. So meanwhile, we'll talk about uh, you know why we need Docker as such to run our applications. Because nowadays applications are becoming heavy, because the amount of data we are getting is huge, and to process that data, we need to separate our tasks in an application in order to make it run smoothly. So there is a basic difference between a container and a virtual machine. As you all guys know, that virtual machine is nothing but a virtual version of a computer. So it's basically containing all the all the base files, your operating system, then all the libraries and apps. On the other hand, container only contains the application and the supporting files. It doesn't contain the underlying operating system, and that makes it very lightweight. And uh, it is using the shared operating system uh, on the Docker engine. So you can run multiple containers on the same Docker engine, like on the same OS. So let's jump into the Kubernetes. So Kubernetes, this is the history of that word. Why Kubernetes, um, uh, from where the word came. So Kubernetes is an ancient Greek word for helmsman. Helmsman, uh, or governor. So Kubernetes is a container orchestrator or cluster manager. So as I told you before, there we are running our application now in microservices based in container. Okay, so in order to manage that containers properly, we need we need a service. So Kubernetes is that service that we are using to manage all our applications and the underlying containers. So places containers. What Kubernetes does is places containers on nodes. A node is nothing but the machines on which our applications are gonna run. Recovers automatically from failure. Suppose a particular machine gets down. So in order to keep our app running, it automatically brings up another machine. Basic monitoring, logging, health checking enables containers to find each other. So it also helps in uh, enabling the communication between the two containers or the two services of a app. So the history of Kubernetes is like it is uh, based on the ideas proven at Google over 10 years. So it is basically built by Google. Everything at Google runs in a container, and Google launches 2 billion containers, maybe more than that now. This 2 billion number is a bit older. Part of a large set of tools that make up the internal Google platform. So mostly all the major applications are underlyingly running on Kubernetes or using Kubernetes. So let's jump on the benefits of Kubernetes. So it provides all these benefits like intelligent scheduling, self healing, horizontal scaling, service discovery and load balancing, automated rollouts and rollbacks, secret and configuration management. So these are the technical benefits that people who understand Kubernetes will know. But for a user point of view, like if you are very new to Kubernetes and you want to uh, you know uh, opt for it or want to make a decision whether to use it or not. So for a user, these are, in layman's term, these are the benefits, like packaging, deployment, and reuse. You can package your app in small containers. You can deploy it anywhere. You can scale it properly, and you can reuse your previously built apps or images, you can say. Then efficiency, Kubernetes is very efficient. So it helps you to efficiently manage your workloads across your environments. And the major part, most importantly, why Kubernetes is so popular is the security, because it provides the isolation between the containers it is running, and that helps in maintaining the security part of it. Now let's talk more about Kubernetes. It is open source technology. Uh, you can check out this link on GitHub to know more about Kubernetes. Very active open source project. It has more than 23K stars, maybe more now. It is Apache 2 licensed, and it is written in Go language, and uh, it is majorly hosted by the Cloud Native Community Foundation. But there are a lot of more contributors now, which who contribute in Kubernetes as a technology. So Kubernetes architecture looks like this. So briefly, if you want to understand Kubernetes, so there are majorly two things, that is a control plane and a worker node. So this is the control plane, which contains all the important services which are useful to run your applications on the worker nodes. Worker nodes are nothing but the machines on which our application runs. So worker node is the machine part, and control plane is the you can say management tool, or you can say management plane, where from where you can manage all your machines in your cluster. So we'll be seeing more about the services uh, which are which make Kubernetes work smoothly. So the master components are uh, these are the master components. API server. API server is nothing but a server which exposes the Kubernetes control plane via a particular API. This is how the Kubernetes CLI or kubectl interacts with the cluster. Cluster is nothing but uh, a collection of machines or nodes, you can say. The etcd is the main database of Kubernetes. It stores the key value pairs and all the other data that present in the Kubernetes. You can also opt for some other type of storage, but this is the main storage database of Kubernetes, where all the information gets stored. Then there is this scheduler. Scheduler watches for pods. So now you might think, what is a pod? Pod is nothing but the very smaller unit of computation of your application. Suppose you want to run a service which is uh, inside your application, like it is a sub part of your application, that is called as pod. So the scheduler watches for pods and finds them a node with enough resources to run. So suppose you have like 10 or 15 machines in your cluster, and as your application runs, it checks for the available nodes and the resources it has, and then it places intelligently the pods on the node to run it. Then there is a control manager. This component is a single binary composed of four subprocesses. So it contains four more controllers. The first one is node controller. The second one is replication controller. So it helps in making the replica set. Then the third one is endpoint controller. The fourth one is service account and token controller. So these are the four controllers which which provide us the facility to control each and everything very minutely and on a granular level. So these are the master components. uh, then there is a worker node components. These components sit on the machines that run our applications through Kubernetes. So the first one is the kubelet, which makes sure all containers are running and healthy. The second one is the proxy. This proxy component is mostly used during the development and testing phase of the applications. While we Whenever we make the applications live, uh, at that time we need to remove it, uh, because it is a uh, vulnerable because of the security point of view. The proxy basically allows communication to the inside network of the cluster. So it helps different nodes to communicate uh, throughout the cluster, and also send the information from one node to another. Then the last one is the container runtime. Container runtime is nothing but uh, the underlying runtime which helps the application run using Kubernetes. So the most common runtimes are Docker, as we discussed earlier, and there is one more, that is Containerd. So these are the basic components. Like, these are the very basic components of Kubernetes, and there are a lot more services, lot more components uh, falls under Kubernetes. So these are the more concepts that you can learn about. So that is role based access control, multiple schedulers are there, service scheduling constraints. uh, in multiple schedulers, you can say, based on the affinity and anti-affinity pointers, the scheduler works and schedules all the jobs of an application on the nodes. Then there is stateful state, automatic cluster scaling. Scaling is nothing but, suppose you are getting a huge load on your application, and you want to process a lot many requests at a time. So you can automatically scale your cluster to serve those big number of requests. And then after that peak time passes, you can automatically scale down your clusters to get back to a normal state. Then there is a cloud provider integration. So Kubernetes as a core is very difficult to manage, but you can manage it very easily with some third party cloud providers like Google Cloud Platform, Azure, Microsoft Azure, and AWS. So what it provides is, it is a fully managed service given by these cloud providers that will help you to focus more on your your workflow than the underlying technology or underlying services. So that gives you a more mind space and time to spend on your application development rather than just managing the infrastructure. And there are many network policies also that you can read more about in Kubernetes. So these are the references from where you can uh, learn more about Kubernetes. So the first one is the official documentation. So where you can go and learn more about the tutorials, like how you can create a simple app, how you can deploy your app, how you can update your app. So these kind of scenarios you can learn about. Then the second one is the official GitHub repository of Kubernetes. The third one is the GitHub repository, which contains the real world example of projects that you can start with to build your understanding and more to increase your knowledge in Kubernetes. So that is it from my side. If you have any questions, you can let me know. So I'll just stop sharing.
Thank you, Nilesh. Thank you for giving an intro for the AKS. And I think it's time for us to wrap up the show because there's a lot of things that can be discussed on Kubernetes 101, and you can start your contribution as well as you can also learn about different integrations as well. So in the meantime, when there's an AKS cluster that is coming up, I would love to ask you like, what's your experience in how to connect with you? You can connect with him on LinkedIn. So you can type in your LinkedIn in the stream there that's happening on Build Piper, so people can get through that, or else you can just reach out to him on LinkedIn at Nilesh Shinde. That's his name. So it's NILESHSHINDE. That's his name. So it's the same name. All right, my AKS cluster is up and running, my folks. So it's time for Nilesh to go have his cup of coffee in his home.
Yeah.
So we can
Now
just,
you guys can enjoy the demo that Vishwas is going to do, and also
yeah,
you can I have put my LinkedIn in the chat. So if you want to connect with me, discuss more about community stuff, discuss more about Kubernetes in general or other cloud technologies, feel free to reach out. And also you can reach out to Vishwas, is like the pro in AKS kind of stuff. I'm still exploring, learning, but yeah, I'll be definitely happy to discuss things with you. So yeah, guys, it's over to you, Vishwas.
thank you so much, Nilesh. And I'll remove you from the stream. So bye then. Bye.
Bye, guys.
Bye bye. So, in a meanwhile, let's just start with the stream. I'll start my share screen. Wait, I'll just go on with the window so that it is there with you folks. And here you go, my friends. This is an AKS portal that I was talking about, but I would always suggest you start with a case study on Kubernetes, because a lot of times when you talk about where is the experience of Kubernetes going to help me, it's through the case studies. Why? I'll say why. Because a lot of times I feel Kubernetes is the most under understood technology in the world of distributed systems, and it's been abused very well. Like everybody wants to get inside Kubernetes, but nobody knows the right way. So I would start with a case study and I would just go on with it. So if you can just go with the booking.com, I think there was one Cupid or something that was one of those case studies, and they had a fantastic case study. So you can see that how the challenges were already seen, how the solution was actually taken place, and how they tried in getting that Kubernetes in their infrastructure, and the impact that they had. Despite the learning curve, there has been a great upstick in the adoption. That means, I'll say you one thing. Kubernetes happens to be an experience of 15 years of distributed system in your kubectl command, and that's it. Do not overcomplicate that. The moment you overcomplicate it, it becomes more not so easy to understand. So let me just go on with this uh, connect button. So the moment you click on this connect button, what happens here is very simple. You'll be given a list of credentials and you can just go on with it. So let me just go on with connecting my credentials out there here. Easy CLI. Easy is not getting recognized. That means, all right, let me just share my complete screen so that you will get to know what's happening. So stop the share screen and let me just go on with the complete share screen here so that you will understand what's happening. So that's perfect. And let me just stop the share screen. And wait, it's now visible. That's perfect. So you have to just go to a CLI and you have to just install the things stuff. That's it. Easy CLI. Your command line interface is a must installation for Windows. Why I'm saying you is because to me, I can't really go on and run an hefty workload on my system, and my system starts hanging during the stream, and that's unimaginably untolerated by myself itself. Like, I can't wait for the commands to go for another 10 years down the line. So I can't be there. So let me just show you what's happening. So what's happening here is it's now giving you an access to an Azure infrastructure into your infrastructure that you never ever had imagined. That means like your tiny teeny little laptop has an access to the Azure infrastructure that you're paying for. That's the power of cloud computing. So even Azure faces scalability issues. Even Azure faces a lot of network glitches, but still there is a set of distributed systems that are rigged up, that are written in terms of software and the hardware, and they are just working. And this helps you in getting the access to that infrastructure which you never had ever imagined. So the moment I say open in 8 seconds, it will just be there, and I'll just do the same thing. As AZCLI. I don't know why AZ didn't work, but let me just go to the PowerShell, and yes, it should be working for me right now. And the moment I click on this, it can be working for me. I think actually you should ask me for AZ login, and if the AZ is not coming, yeah, of course, yes, then the command line is not being installed and things like that. So not to worry, it's just 2 minutes of steps. That's it. Don't worry about that. So copying new files and everything. So this is now adding all the credentials that is required and accessing the Azure system and updating the components and the registration. That's what it's doing. I wanted to do it like an full on full basic to advanced session so that you get to understand, okay, this is what it takes to be there on an Azure infrastructure right now. And hopefully there is nothing that is getting wrong, because there can be some things like, okay, some firmwares did work and things like that, but in the meanwhile you can actually go on to one of the forms that we have created here. I think I'll just share the Google Forms. All right, this is not the one. This is not the one. What is CS? What is the CI/CD that you think about? Your view about the CI/CD tools today, and what is the requirement? So it's just some of the responses that I just collected, but you can just think about your views on the CI/CD tools today. So you can just talk about what is the requirement of the hour that you when you see, okay, this is what I need when I'm talking about an infrastructure that is just going to change in my everyday life. You can talk about it. You can really give some set of an insights here. So this is the link, my friends, and I'll be sharing it on LinkedIn as well. So don't worry. But till the time the Azure CLI has got itself registered, yes, of course, it got registered. So let me just go to my LinkedIn so that you can start getting where is the work done. So that's the whole point here. So yes, and there you go, folks. All right, I posted something. So let me just share my entire screen so that you will be able to see what's happening. So it's been done. So let me just go to AZ login. Oh, it's a new command line that I need to open, or else it doesn't recognize that. Easy login, and now it magically opens me a browser tab, which is just going to give me an access to Azure infrastructure right now. Just see the magic of it. It's just easy, and of course, creating new history 123 and logged into the Microsoft Azure. And let me just see the magic of it. So there's tenant ID of mine, there is home tenant ID, subscription ID, and things like that. So don't worry, this account will be deleted the moment you are the nothing can be accessed at all. So don't worry about that. So in a meanwhile, let's just rig up everything from the infrastructure that we had. So this is where you start, and this documentation thing in the Kubernetes tab is going to be a Bible. So do not mess with this. So this is love. Love this. If you are a Kubernetes person, if you are not into the documentation, sorry for that. You are not an engineer, by the way. It's all documentation. And if you want the enablement of that, just reach out to us at Ops3. We help you in empowering you in terms of that. So that is the thing. So it's a command line done. So let's do one thing. Let's just go and create some things here so we don't mess up with some credentials and things like that. So this is a storage account that's just getting created for me so that all the inputs that I give, all the configurations that I give will just be in the storage account compute. And it's not affecting me or you in any form or the other. So in a meanwhile, there is a lot of things that's changing. You can drop me a mail or anything where we can just go and talk about things which are also working for you in your company, or if we have anything to help. And also there's a Redis consultation that we are actually going ahead with, so you can go there and check that out. So I just gave you a heads up so that you don't miss out on the things. So let me just go to the incognito tab so that it doesn't do that. So Bill Piper by Ops3. Sorry for my cold, and I have a very bad cold, and I had to work out. All right, this may be Kubernetes. Kubernetes. It's been a tough thing. All right, it's not here. So let me just go here. So our Redis operator is also an open source release has also been here. You can check that out, as well as we are very sorry for that. It's not co-workers. We need the post, right? So here's the one. Here's the Redis cluster which is just coming up for me, and it's there for getting the things there. So just go ahead and let me just go on with the subscription ID setting. And all right, 7-1, and I have to easy. And there you have it, my folks. I've already set with the subscription. Easy AKS, get credentials, Vishwas, Vishwas, it's already done. kubectl gets deployment. So it's already saying that I'm actually getting all the deployments that are done in the different namespaces. That means every little deployment that has been separated out in terms of the namespaces, I'm now getting it. And of course, these are the default namespaces that just gets created the moment you get in. In the meanwhile, let's just go to the AKS starter demo, or else we can say AKS quick start. I'll tell you why I am just telling you this, because the moment you start thinking about where is the entire infrastructure going to be, it's going to be there in the form factor this. So I just want you to learn about all this. So simple as that. It's an voting app that's been shown above cats and dogs. But look at the fact it's an voting backend as well as front end, which is being considered. And the kind of it is deployment. And in the same YAML file, services are also getting deployed. That means you are strategizing both the backend of the server, the backend of the service, and the backend of the deployment in one YAML file. That means you're also saying this is the memory that I need for the resources to be there, and these are the number of ports that I want when the infrastructure is up and running. Let me just go red. Red looks good. And guess what? This is the Redis cluster that we are just caching on. That means if there is something that is just being there for me, Redis has to store it. And I think that's one of those best demos that you can ever look forward to. So I'm just using it because just by reading this entire documentation properly about this entire demo, you will learn a lot at the end of the day. So let's just go nano, and it's Azure Vote.yaml. I think so. Azure.yaml. That's what you want. And yes, I pasted, and I control save, wrote 85 lines, control X is to exit. That means I do cat Azure Vote.yaml. You can see the entire thing has been written for me, and the front end of it is also given as the service. This is the entire code for it. Like probably this was supposed to be there in one more YAML file, but since there's an demarcation that we just got added between this, sorry for that. I just forgot some of the commands on this thing. Between this and this. So these are the two demarcations that just got defined from the three dashes. And this defined only in one YAML file. And that's the magic about your Kubernetes and the things like that. So what it is all about next is to just put this command. I'll just say what is this command all about. qctl apply minus f azure vote.yaml. This file is a manifest file. And this is a command that says we are going to apply a file to it, and we are just going to have an access to an entire hardware resources that is just getting defined from this manifest that is there and defined here. That's the same thing, which is just going to be applied onto a namespace. Or else there is a step where you can also define a namespace here and things like that. We can also do this node command as well. So we'll go on with that as well. So let's just do this kubectl apply Azure mode. And it's a very fast process because it's running on cloud. Probably if I had run it on my system, it would have had not crashed, but since I'm streaming, it would have made it very slow. And don't forget to go to the buildpiper.io/DevOps champions. That's awesome. That's a new initiative that's coming up, but blocks. Let's go to the blocks because that would give you a lot of insights about how an Helm packager is getting used. Okay, Helm. So wait. So that is from Bhupendra Rawat, one of our dearest friend, post by me. All right. I had an Elm sketch. I don't know where it is today. It's every place. I don't know. Let me just go on with it. So, Helm chart. Helm charts are here. So, it's a simple story. You are just having a chart repository. You are just having a CLI support. That's your Helm CLI. And you're logging into different Kubernetes clusters and you're managing the packages out there. So this is where you get a chance to learn a lot about AKS and things like that. So let's go on with it. Let's go on with the demo so that we just get here. So you can go to the resources, you can go to the blocks, and you can learn a lot. You can learn a lot from here, by the way. A lot from here. I think this article on supply chain securities, everything related to Kubernetes is here. So don't worry about it. All right. So this is happens to be event-driven order scaling. So in one of this, I've used how to add a repository of charts. So let's go on with that. So I do the same thing here. I just click on this, and guess what? It now added an Helm chart of Kira core. Okay, so Prometheus and Grafana is a different story. So Kira can also be done. So that's a different story. That's I have to just look for the block. So I'll just stop the share screen so that I can't compromise anything else. So all right. So let me just go on with this so that I'll just get a brief comment about where it is supposed to be headed. So yes. So I think yes, that was in my GitHub repository. Sorry for that, I can't share you that. But I think we can go ahead with this one. So yes, my friends, let me just share my screen so that we don't have anything to be taken care of. So I just clear it off and I'll just show you one more thing. So let me just go back here and then let me just paste this command here. So Prometheus community Kubernetes stack. So Helm was not installed. Prometheus community stack is not here. So let's just try this. Okay, what is wrong with this? Okay, Helm update. No such files to be updated. That's good. But why is it coming? Failed to download Prometheus community.kubernetes stack. I think it's just taking a bit more time here. So we can go ahead with Kira demo as well so you guys can understand what it is all about. So yes, let's just go on with it. So I'm just installing it. Done. I'm just going for the Helm repo add updates. Oh, I think I misspelled that. I think that's repo update. Not updates, update. Sorry for that. In kubectl, create namespaces Kira, and that means everything is happening in the Kira here. That is just getting done here. So let me just do that. And in the meanwhile, helm install Kira core on the namespaces Kira. So what I just did was I just took the Helm repository and I started working on the Kira aspects here. In the meanwhile, you can just go to the Azure ML ode and everything is written here, right? So let's just do one thing. Kubectl get ns is the namespaces, and there you have it. Kira is now generated for me. You can just go here in one of the repositories and you can do it, or else you can go to one of my LinkedIn article and you can just copy it directly as well. Okay, this is my, not my account, this is my this account. So let's just go on with it. Yeah, it's something that I, all right. Let's just do one demo so that we just get everything sorted. So we have nanoscaled objects. So it's nanoscaled dot YAML or YML, anything works. So I'm saying it's a name of a sandbox API and type is the memory utilization and everything is getting defined here. So that means kubectl apply minus f is dot YAML, and guess what? You're now just getting the scaled objects. So kubectl gets scaled objects. So there you have it. You just created yourself a memory scaled objects. That's one of those scaled objects that is just getting created, and scale scale it. Scale target name is sandbox API and triggers are memory here. This is just a setting up of a memory, but there is a CPU trigger as well that you can add and everything that can be done. So it's just one change of a command for CPU. That's it. It's just one CPU, just change of a command. Nano scaled object dot YAML, and I say type. It's CPU. I'm just saying you this resource allocation and everything can be done easily because most of the time it's just memory now. The moment I apply this and I get this, it's CPU now. That means leveraging the resources on a Kubernetes clusters is also much more easier and faster. Let's say CPU is turning up and you want the best of the best resources to be there in front of you. It's not ultimately just one single step that's going on right now. So it's just years and years of work. So this is where that experience comes up and says, you know what, if there's a CPU trigger, then let's just trigger something or a Kubernetes to just scale up the pods or something else. So this is where Kubernetes gives that leverage for you as developers to get inside the infrastructure. So let's do one thing. Let's do one last demo so that we just make sure that this demo works fine for us. Helm install Prometheus. Okay, there's an academy, which is good. Okay, artifact app.io. So let's do this. Let's do this and let's just run this on the local host so that we can gather some information. Oh, that's been added. What happened to my demos today? All right, not a problem. Admin and password is password. Password and level update. All right, so let's do one thing. Let's connect it locally so that we have that entire leverage of this thing. So I just add it here. That's perfect. I'm getting the credentials. That's very awesome. I just got myself credited. kubectl. I just go to the other thing, it doesn't work. kubectl, it works. kubectl is not, oh, sorry, not kubectl. It's recognized. Oh, it's now getting recognized in my CTL. Let me just go in a partial. If it's recognized, then it's on my system. That's it. kubectl. I didn't install anything, by the way. Like, I didn't install. Okay, this is getting recognized. I think I need to port forward some things. That's what it was. I need to port forward. Let me just go here and see what is how to port forward. Port forward in Prometheus. It's a very simple thing. Forwarding from Cube for forward Prometheus services Grafana to all right 3000 something port. Let's see how this thing works. kubectl port forward -n Prometheus. kubectl, oh, not cube, it's already there. kubectl get ns. Okay, this is perfect. Okay, so I understood that. Okay, I didn't install it correctly. I think let me just go to some instances where I can just get some help about installation. Let me just go here. Okay, K21 is popping like anything. Okay, so add Prometheus community. Okay, update. Okay, we can do this one because I think this is what can work for me because deployments is what we obviously can care about. Error not found. Deployments.app. Grafana is not found. Then why is Grafana coming? All right, let's do it here. What already existing? And how did this come up? I was just wondering how is this coming up? Even I don't know. Did I do this one or which one? Okay, let's do one step ahead. Okay, let's do one thing. Let's just stop this demo because it's just namespaces after namespaces added and things like that. Probably it's just adding more complexity to the time. So don't worry, folks. And detailed demo of an or a workshop session will be delivered by us in order to get you the things. Or else you can just go to the resources here in the tab. In a meanwhile, in the resources tab, use the workshops tab here. Just go and find anything on Prometheus, Grafana, or else Elasticsearch is there. Microservices monitoring, best practices, Terraform ISE. There's a lot that we have done as a workshop, so you can just go ahead and grab any of the resources that we have. Thank you so much, folks. We are ending the broadcast now.